In a commercial building with a 600 amp 208/120 volt 3-phase 4-wire service, when installing a 175 kilowatt generator with a 600 amp automatic transfer switch, overcurrent protection is indeed required between the utility transformer and the transfer switch. This requirement is outlined in the National Electrical Code, specifically in section 700.12, which addresses overcurrent protection on the supply side. The National Electrical Code 700.12 mandates that the supply-side overcurrent protective device or devices must be installed at a readily accessible location. This location should be ahead of the distribution panel board or switchboard, and it can be either within or outside the building or structure. This means that the overcurrent protection needs to be easily reached for inspection, maintenance, and operation. The primary purpose of this overcurrent protection is to safeguard the electrical system and equipment from damage caused by excessive current flow. This can occur due to various reasons, such as short circuits, overloads, or ground faults. Without adequate overcurrent protection, these faults can lead to overheating, equipment failure, and even fires. The overcurrent protection device or devices must be rated for the maximum ampacity of the service conductors. Ampacity refers to the current carrying capacity of a conductor, which is determined by its size, material, insulation type, and installation conditions. The overcurrent protection device must be capable of handling the maximum current that the service conductors can safely carry without exceeding their temperature rating. Selecting the appropriate overcurrent protection device rating is crucial to ensure effective protection. If the rating is too low, the device may trip unnecessarily, causing nuisance outages. If the rating is too high, the device may not trip quickly enough to prevent damage to the equipment and conductors. Coordination with the generator's onboard main breaker is also essential. Coordination refers to the process of selecting and setting the overcurrent protection devices in a way that ensures that the device closest to the fault will trip first, isolating the fault and minimizing the impact on the rest of the electrical system. In the context of a generator installation, coordination means that the generator's main breaker and the overcurrent protection device between the utility transformer and the transfer switch must be selected and set so that they work together to protect the system. For example, if a fault occurs on the generator side of the transfer switch, the generator's main breaker should trip first, isolating the generator from the fault. If a fault occurs on the utility side of the transfer switch, the overcurrent protection device between the utility transformer and the transfer switch should trip first, isolating the utility from the fault. To achieve proper coordination, a coordination study is often performed. This study involves analyzing the electrical system and calculating the fault currents at various points in the system. Based on these calculations, the overcurrent protection devices can be selected and set to provide the desired level of protection and coordination. The overcurrent protection device typically used in this application is a circuit breaker or a fuse switch. A circuit breaker is an automatically operated electrical switch designed to protect an electrical circuit from damage caused by excess current from an overload or short circuit. Its basic function is to interrupt current flow after a fault is detected. Unlike a fuse, which operates once and then must be replaced, a circuit breaker can be reset either manually or automatically to resume normal operation. Circuit breakers are made in varying sizes, from small devices that protect individual household appliances up to large switchgear designed to protect high-voltage circuits feeding an entire city. A fuse switch is a type of electrical switch that incorporates fuses for overcurrent protection. The fuses are typically mounted within the switch enclosure and are connected in series with the switch contacts. When an overcurrent occurs, the fuse blows, interrupting the circuit and protecting the equipment and conductors downstream. Fuse switches are commonly used in industrial and commercial applications where a combination of switching and overcurrent protection is required. The selection of the appropriate overcurrent protection device depends on several factors, including the voltage, current, and interrupting rating requirements, as well as the specific application and the available space. The interrupting rating of the overcurrent protection device must be high enough to safely interrupt the maximum fault current that could occur at that location. In addition to the national electrical code requirements, there may also be local codes and regulations that apply to generator installations. It is important to consult with a qualified electrical engineer or contractor to ensure that the installation complies with all applicable codes and regulations. Firstly, ensure compliance with National Electrical Code Section 700.12 regarding overcurrent protection on the supply side of emergency systems. Secondly, install the overcurrent protection device or devices at a readily accessible location ahead of the distribution panel board or switchboard, either within or outside the building or structure. Thirdly, rate the overcurrent protection device or devices for the maximum ampacity of the service conductors. Fourthly, coordinate the overcurrent protection device or devices with the generator's onboard main breaker to ensure selective tripping. Fifthly, conduct a coordination study to determine the appropriate settings for the overcurrent protection devices. Sixthly, consider using a circuit breaker or a fuse switch as the overcurrent protection device. Seventhly, verify that the interrupting rating of the overcurrent protection device is sufficient for the maximum fault current at the installation location. Eighthly, comply with all applicable local codes and regulations related to generator installations. Ninthly, consult with a qualified electrical engineer or contractor to ensure proper installation and compliance. Tenthly, document all calculations, settings, and coordination studies for future reference and maintenance. It's important to understand several key aspects related to this requirement. Firstly, the purpose of overcurrent protection is to safeguard the electrical system and equipment from damage caused by excessive current flow. Secondly, the location of the overcurrent protection device must be readily accessible for inspection, maintenance, and operation. Thirdly, the ampacity of the service conductors determines the rating of the overcurrent protection device. Fourthly, coordination between the generator's main breaker and the overcurrent protection device is crucial for selective tripping and minimizing system disruptions. Fifthly, a coordination study helps determine the appropriate settings for the overcurrent protection devices. Sixthly, circuit breakers and fuse switches are commonly used as overcurrent protection devices. Seventhly, the interrupting rating of the overcurrent protection device must be adequate for the maximum fault current. Eighthly, local codes and regulations may impose additional requirements for generator installations. Ninthly, consulting with a qualified electrical engineer or contractor ensures proper installation and compliance. Tenthly, documentation of calculations, settings, and coordination studies is essential for future reference and maintenance. When determining the appropriate size of the overcurrent protection, several factors must be considered. One factor is the continuous load on the circuit. The overcurrent protection device should be sized no smaller than 125% of the continuous load. This is to prevent nuisance tripping due to the normal operating current of the circuit. Another factor is the inrush current of any equipment connected to the circuit. Some equipment, such as motors and transformers, draw a large amount of current when they are first turned on. The overcurrent protection device must be able to withstand this inrush current without tripping. The type of overcurrent protection device also affects the sizing. Fuses typically have a lower interrupting rating than circuit breakers. This means that they may not be able to safely interrupt a high fault current. Circuit breakers are available with a wide range of interrupting ratings, so it is important to select a circuit breaker with an interrupting rating that is adequate for the application. The National Electrical Code provides detailed requirements for the sizing of overcurrent protection devices. It is important to consult the National Electrical Code to ensure that the overcurrent protection device is properly sized. In addition to the National Electrical Code requirements, there may also be local codes and regulations that apply. It is important to consult with a qualified electrical engineer or contractor to ensure that the overcurrent protection is in compliance with all applicable codes and regulations. The overcurrent protection device should be inspected and tested on a regular basis to ensure that it is functioning properly. The frequency of inspections and testing will depend on the type of overcurrent protection device and the environment in which it is installed. Circuit breakers should be tripped and reset periodically to ensure that they are not sticking. Fuses should be inspected for signs of damage or deterioration. If an overcurrent protection device trips, It is important to determine the cause of the trip before resetting it. If the cause of the trip is not corrected, the overcurrent protection device may trip again, or it may be damaged. Overcurrent protection is an essential part of any electrical system. It protects the equipment and conductors from damage caused by excessive current flow. By following the National Electrical Code requirements and consulting with a qualified electrical engineer or contractor, you can ensure that your electrical system is properly protected. The coordination study should take into account the characteristics of all of the overcurrent protection devices in the system, including the utility's overcurrent protection devices. This will help to ensure that the overcurrent protection devices are properly coordinated and that the system is protected from overcurrents. In addition to the overcurrent protection requirements of the National Electrical Code, there may also be local codes and regulations that apply. It is important to consult with a qualified electrical engineer or contractor to ensure that the installation is in compliance with all applicable codes and regulations. The overcurrent protection should be inspected and tested regularly to ensure that it is functioning properly. The frequency of inspections and testing will depend on the type of overcurrent protection and the environment in which it is installed. Circuit breakers should be tripped and reset periodically to ensure that they are not sticking. Fuses should be inspected for signs of damage or deterioration. If an overcurrent protection trips, it is important to determine the cause of the trip before resetting it. If the cause of the trip is not corrected, the overcurrent protection may trip again, or it may be damaged. Firstly, overcurrent protection safeguards electrical systems from excessive current. Secondly, accessibility is key for inspection and maintenance. Thirdly, conductor ampacity determines protection device rating. Fourthly, coordination ensures selective tripping during faults. Fifthly, coordination studies aid in setting appropriate device parameters. Sixthly, circuit breakers and fuse switches serve as protection devices. Seventhly, interrupting rating must match maximum fault current. Eighthly, local codes may add installation requirements. Ninthly, professionals ensure compliant and safe installations. Tenthly, documentation is vital for future maintenance. In summary, installing a generator with an automatic transfer switch in a commercial building requires careful consideration of overcurrent protection. Following the National Electrical Code guidelines, conducting coordination studies, and consulting with qualified professionals are essential steps to ensure a safe and compliant installation. Remember, proper overcurrent protection not only protects your equipment, but also safeguards the building and its occupants from potential electrical hazards.